Okay, welcome to Rice 101 module number 10. My name is Griffiths Atungulu. I'm the director of the Hawkins Rice Processing Program. I'm an associate professor and agricultural engineer. My area of specialty is in grain processing and post-harvest systems engineering. I'm housed in the Department of Food Science with the University of Hawkins Systems Division of Agriculture. In this module number 10, we are going to look at rice milling quality assessment. And in so doing, we are going to look at methods that we can use to evaluate milling efficiency and also go about describing a very important terminology in rice processing called the degree of milling. So to begin with, let's look at rice milling assessment. Good milling ensures that we dehusk and polish that rice without breaking it. As we learned in the previous modules, rice is comprised of different sections. We have the husk, then we have the bran, then we have that white endosperm, and of course the germ. And so in the milling process, we remove pretty much the husk, and then we start subsequently removing part of the bran. And good milling yield really has an objective of ensuring that the maximum value is obtained, and the goal is to yield a high amount of whole kernels. We want to look at some of the parameters for evaluating the efficiency of the milling process. The first terminology here is going to be the brown rice yield. In some cases, we describe that as the brown rice recovery. It's basically the percentage of brown rice to rough rice. And the way we calculate that is get the weight of the brown rice, divide that by the weight of the rough rice, and then multiply that by 100 to get the percentage value. And then we have the milled rice yield. The milled rice yield is basically the mass percentage of rough rice that remains as milled rice, often referred to as total yield. And the way we calculate that is, first of all, get the milled rice mass, and divide that by the rough rice mass and multiply that by 100. And then a very, very important parameter, the head rice yield, and very briefly we'll be describing what head rice actually means, but it's the percentage of head rice to rough rice. It's one of the most important assessment criteria of rice milling. It basically determines the market value of our rice. Domestic as well as international markets would prefer having higher head rice yields. The reason for that is because the market value of head rice is twice that of block rice. Head rice, by definition, again, as you can see here, is the milled rice kernel that are at least 3/4 the original length of the milled kernel. It's often referred to as whole kernels, or in some literature as fancy. And so head rice yield is the mass percentage of rough rice that remains as head rice. And you can see in that equation there, head rice yield is calculated by taking the head rice mass, dividing that by the rough rice mass, multiplying that by 100. The figure on your right there shows some of illustration of what a head rice would look like. Of course, on the rightmost, you see a whole kernel without any chips or any breakage. But then in the middle section there, you see a kernel that has got a chip on the bottom end. But as long as that chip is such that the length of that kernel is still greater than 3/4, or at least 3/4 the length of a milled kernel, it is considered as a head rice yield. The leftmost there, you can see another case of a chipped kernel, but then on the top side, again, as long as the length is 3/4 or greater than that, 3/4 the length of a whole kernel, we would consider that as a head rice. Let's talk about the degree of milling. The degree of milling often is the extent to which bran is removed from the brown rice. As you can see that picture illustration, it shows us there are brown rice with the bran on the surface. And so as we continue milling, we remove the bran, and we also remove the germ section of that rice as we proceed towards the endosperm. And so the more the bran that we remove, the higher the degree of milling. And so we can see towards the end, we end up with a white rice kernel where we have removed almost everything. We removed the bran as well as the germ. And there are various methods that are used to estimate or predict the degree of milling. Three common methods that we will find in the academia as well as in the industry include, number one, visual examination, as we could anticipate. The more we remove the bran, the surface color characteristics are going to change. And so we can use visual estimation as one of the ways to determine the degree of mailing. The other method is the chemical composition. The bran has predominantly lipids, and the more of that we remove, the less the lipid content remains on the surface of the rice kernel. And then there are optical measurements. Of course, as you continue removing the bran layer, the color changes, and any light that is projected on that surface will either be reflected or absorbed or transmitted. And so we can use that physical characteristic to estimate what the degree of mailing is. Now, there's the FGIS classification of the degree of mailing, the Federal Grain Inspection Services. They classify primarily based on the meal rice color. And they have three categories of classification, which are based off of their standard estimation chart. And the first category there is the reasonably well mailed. And that is when we still have a darkish color of the rough rice surface. As we would expect before we remove the bran, it will look slightly darker. But the more we remove that bran, we tend towards the white part, which is the endosperm. So we have the reasonably well mailed, which is the darkest color. And then we have the well mailed. And then we have third category there, which is the hard mailed, where we have the lightest color of that kernel. Now, the FGIS system, as you can notice, is rather subjective, may be skewed by pre-harvest and post-harvest environmental conditions, which affect the kernel color. For example, if that kernel had discolored, or if it had gone through some disease, or just generally affected by any processing procedures, then you would expect that color not necessarily to reflect the degree of mailing. And so to be able to minimize this kind of subjectivity, there's need to have some measurements using optical or color metering devices. So let's look at surface lipid content a little bit more in details here. As again I mentioned, it's the mass percentage of milled rice that is lipid remaining on the surface of the kernel. So as milling progresses, we expect the degree of milling to increase, the surface lipid content to decrease. Now, as the surface lipid content decreases, the bran along with some of the endosperm is removed, and so we expect the milling, milled rice yield as well as the head rice yield to decrease. There are various methods we can use to estimate the surface lipid content. The conventional methods that are available in literature or in the industry as well as in the academic world involve the use of the goldfish method as well as the Soxhlet method. Basically, these are methods that involve extraction of the lipid and quantifying it and getting an estimation of its mass relative to the mass of the brown rice that you started with. These methods are rather costly and labor intensive. They're inefficient in a production environment because they may not be able to compete the high throughputs that are in those environments. So there's a rather simpler method, and this is a technique that uses an NIR. This is a rather rapid method. It provides very rapid results. It's easy to use, and is one of the most preferred by the rice industry. This figure here illustrates a very important phenomenon when estimating the surface lipid content of rice. On the x-axis, there you see the milling duration. On the y-axis, you see the surface lipid content. What this figure is trying to illustrate is that different rice cultivars are going to mill differently. And so the degree of milling has to take into account the fact that those cultivars will mill differently. And so the duration that is required to achieve a similar degree of milling has to be determined for us to be able to do a better comparison of the head rice yield. So essentially, if all samples were milled for a set duration, typically of 30 to 40 seconds, as you would see from this figure, some samples will be over-milled relative to the others, and this would cause inequitable head rice yield comparison. And so briefly, let's look at some of the factors that impact the degree of milling. As we've seen in that previous slide, milling duration is very, very important. The pressure within the mill, and these again are factors that would play a great role in laboratory assessment of milling. And so the pressure within a mill, in a case where you're using a McGill #2 There's usually a pressure lever, a lever that you put a weight on, and that weight helps us to establish a pressure within that meal. The higher the pressure, of course, the more the friction you expect within the kernel and also the friction edges of the meal. And so the higher the pressure, of course, you expect more degree of milling. So that would be a factor to consider. The other thing is the initial sample mass. Of course, if you put a lot of samples inside there, you would expect maybe more friction, and the degree of milling for the same set of duration might be different if you had less samples inside there. Again, we found out from our laboratory studies that the brown rice temperature is an important parameter. Colder rice tends to mill less, and so it's recommended that when you store rice, you get it from the storage, you place it in an ambient condition, let it equilibrate before you place it in the mill. The last part there is the rice cultivar or cultivar mix. Again, as we've seen in the previous slide, different rice cultivars are going to mill differently, just because they have different characteristics of the bran layer, and especially the bran layer thickness. With that, I want to leave you with the following references that I would recommend that you go through if you want to get more information on the subjects that I've covered today. And again, I want to say thank you very much for listening to this module. I look forward to talking to you in the next modules. Thank you.